before they even start digging into the AWS database services. Now, because of the start of the cloud services, people are moving towards cloud. So there will be very thin line between DBAs and other administrators. So we are supposed to know a bit of the basics, and then we can move towards the specific service. So we'll talk about the relational databases as well as the non-relational databases, and see what are those and what are the differences, right? Your relational databases or SQL, the structured query language databases, they are, as the name suggests, they are structured databases, and your NoSQL would be unstructured databases. They normally use a structured query language, and they most of the time you will see them with this NoSQL or non-relational databases using JSON kind of data structures. Then your database in RDB or SQL based databases would be containing a table, a column, which is nothing but a field or data point, as well as a row or record. So it's like some same thing which you see in the actual sheets. While your non-relational databases will contain collections, documents, and key value pairs. Okay, so connections can be like tables, then documents would be like your column, and the key value pair would be the values as well as the keys. So which you see in the JSON kind of documents. So these are vertically scalable, and this can be horizontally scalable. So what does it mean basically? In terms of the performance, if you find there's a relational database and it's having performance issue, you can vertically scale it most of the time. I mean, you can increase the CPU and RAM, but it would be very difficult to increase the number of servers to support it. While with the because your non-relational databases, they are not that structured and schema is not that rigid, you can use your you can use multiple servers to support the database workload rather than keep on increasing the CPU and other resources. Because vertically scalability has a limit. At some point of time there would be a point where you cannot add additional resources, while this would something which give you a lot of flexibility in terms of that. Plus, when you create a vertically scalable resource, it still becomes a single point of failure, while when you have horizontally scalable or scaled resources, you will not have a single point of failure. Okay, so there's certain benefits and certain comparisons. Then you in database which are SQL based or relational databases, you will find a schema that defines the column and data types that every row in the table must conform to. Means what? If your relational database would something look like that. It's like your actual sheet where you have to define how many columns you need, whether you want ID, name, database, or is active or not. And then once you define that structure, every value has to be filled. You cannot leave a blank value. If there's nothing you have, you need to put a 0, but you cannot keep it blank or cannot have a field or without any values, because of the schema they follow. While that is not the case with the NoSQL databases, you can have ID, name in one field, I mean in one key data structure. In the second one you want only ID and databases, or name and databases. That way you can have that flexibility, right? So if at all you want that some field you do not need a field like there's a date of birth in one of your users, you can get rid of it without even worrying about the database functioning. Okay, so if you don't need something, the schema allows you to be flexible, and you can add more fields, you can remove more fields in case of a NoSQL based databases. Then this has got very strong consistency. When strong consistency means the data would remain consistent once it is inputted. What you see basically is the exact state of the data, while this would have eventual consistency, your NoSQL based databases. So it might be, and reason being, because if you are using this horizontally scalable and there are multiple servers around to support your database workloaded, and you are updating inputting those values on one of the servers, it might take time before it gets updated to the other servers. So that's why it would have an eventual consistency, while this will have a strong consistency. Your existing database apps, financial applications like ERP, etc., they would be using relational databases or SQL based databases, while this would be basically for the web applications, social media applications, and mobile applications. So if you got a scenario in your exam which asks about to choose a database service which is for the modern social media application, maybe a mobile application, maybe a web application, then most of the time you can make use of a non-relational or a NoSQL based of kind of an offering. Okay. While if it is for a traditional ERP or financial application, then you can think of using SQL based databases or RDS, that is relational databases. That's about the basic difference between these. Now there are another two types of databases which you might come across. One is online transaction processing, and then online analytical processing, that is OLTP and OLAP. Your OLTP will normally required or normally used to record day-to-day business transactions, because its name suggests a transaction processing. So whatever transactions happens based on these kind of databases, you can make use of those kind of databases to record those transactions, like your payments received from customers, payment made to suppliers, product moving through inventory, orders taken, or service delivered. These kind of use cases where you can make, where normally you make use of OLTP. If your OLAP or your analytical processing kind of databases, basically they are used for large business databases, and where they have to run complex queries to analyze certain or a large amount of data to come to some specific reporting, or to giving some reports to management so that they can decide what's happening in the organizations throughout the business. So those kind of a process would require OLAP kind of a databases. These OLTP or this online transaction processing database would be optimized for write and read both kind of an operations, and they would be strongly consistent and highly atomic. While your online analytic processing kind of a database, they can be used to perform complex analysis queries without negatively affecting transactional systems. So basically, they would be read heavy, and they would be kind of a read and write both kind of an operations they will be supporting. But in these kind of scenarios, you will be having more of write operations. Here, you will be more of a read operations. The example for these are SQL, Oracle, etc. And the example of these are basically these are heavy read and low write workloads. An example are your NetWeaver, your SSRS or SQL reporting server, or Oracle Hyperion. So these kind of a databases, they comes into this OLAP category, and these kind of a databases, they come into the OLTP category. Okay, moving further. Yeah, Ravi, kind of, yes. Then we have the another type of architecture which we normally come to see in databases, that is called warehousing, which is basically a centralized repository for data from one or more disparate sources, where you can you can dump lot of data, right? Extremely large data. You can use data warehouse services for those. You can store current and historical data, and you can basically use whatever the amount of data you have there. You normally use it for reporting and analysis purpose, but this would be an extremely large data. As the name says, see, if you look at the warehousing, what is the warehouse is? Basically, it's a place where you dump everything before you bring it to the market, right? This is something similar to that terms. Here you can dump every data, and then you can keep on analyzing or keep on working or with this with that large data to gather reports, to provide output of a business or outcome of a business. All these things you can done. Normally these would be like more of a read heavy databases, but it will contain extremely large kind of a data. And we have a product for this one is Amazon Redshift, which would be covering this particular kind of a use case. If in your exam you find that you need to specify or provide a service for warehousing, then Amazon Redshift would be the appropriate answer for that. Then these are the basically offerings which AWS RDS offers to us. We have Oracle, PostgreSQL, Amazon Aurora, MySQL, MariaDB, as well as the Microsoft SQL Server. So there are 6 different offerings which AWS offers in terms of RDS. Okay, so Amazon Aurora is Aurora's database. Basically, it's an open source kind of a database, or basically it brought into the market to give a base kind of a fight to Oracle and SQL's market share. And Amazon basically quotes that this is a database which will give you the flexibility and the flexibility of an open source database, as well as the pricing of an open source database. I mean, it would be cheaper than the normal mainstream commercial databases, and it would be at par with Oracle and Microsoft SQL Server in terms of performance. And your Aurora comes with the two different engines that is compatible to PostgreSQL and MySQL. If you are currently on these two databases, you can, without any hitch, you can move to them as an Aurora, because it has got two different engines which support both of the workload, either based on PostgreSQL or MySQL. Okay, so this is something which you can have in the RDS offering. Let's talk about the NoSQL based offering that we have. Amazon DynamoDB is a NoSQL based database which you will not be used for your web applications, your mobile application, as well as your social media kind of an applications. Then for the data warehousing offering, which we discussed earlier also, we have Redshift that would be used for warehousing kind of scenarios. Now let's talk about a bit of basics of Amazon RDS, and then we'll jump into the console and see how we can configure one in the demonstration. So first of all, you need to aware something called DB instance. Let's do one thing. Can someone please share the credentials? I will log into the console and keep on showing you the PPT as well as the console itself, so that that can make much more sense, I believe. Can someone quickly share the credentials? Guys, someone has to share. Okay, if you don't want to see the console, let's do it later then. Okay, let's talk about DB instances. So the DB instance basically is the first or the basic building block of your RDS, and you can call it an isolated DB environment running in AWS. So in a layman simple term, this is the EC2 instance or the server on which your RDS will run. Okay, when you log into the console, you will see this by the name of DB instance. But when you see this DB instance, you need to understand this is something which is running in the background on which your RDS or your database engine is running. Okay, that's what is called basic building block of Amazon RDS, and it can be termed as an isolated database environment running in AWS. Okay, then it can contain multiple user created databases. Okay, as I said, this is a background server which we will not be able to interact with, but this would be holding or hosting our databases. So it can have multiple user created databases. It can support all type of engines like SQL, MySQL, PostgreSQL, Oracle, MariaDB, Aurora, etc. And you can have up to 40 RDS database instances in your account. If you need more, you can talk to the AWS support. Your each DB instance will have a DB instance identifier. Basically, this is the name which you supplied and which will uniquely identify your database instance, and it must be unique in the region. Because the DNS name of database which you get, your DB endpoint name would be based on this naming convention which you provide as an identifier here. Then when you create a database instance, RDS creates a master user account for your DB instance, and that master user account will have permissions to create databases and perform create, delete, select, update, and insert operations. Okay, if you have been familiar with database operations, this is something which you know that every admin user can perform all these actions. But because here the server is not which is we are able to log in, so RDS gives you a master user account for your instance, and that master user account automatically given permissions to perform these actions on your databases. Okay, then your RDS supports access to databases using any standard SQL client application, and this is very important. RDS does not allow direct host access. I'm telling you again and again, if you are using RDS, you will not get direct host access. I think, okay, cool. So okay, now I have got two credentials. I'm going to use one. So let me finish now because we already started now. I wanted to show you from the beginning. Now let's finish this and we'll log into the console. So out of these couple of things which is very important, first of all you need to understand what an instance is, because instance is not database. It's an instance on which your database will run. Second thing, you will not be allowed to SSH into that instance. You cannot. Okay, you can only interact with your databases or the database engine which you select to run. Okay, and if you need to connect to their databases, you would have to use a standard SQL client application. Every database, you know, that will have a something or some or other client applications which can allow you to interact or connect to your databases. Okay, so you can use those things, but you will not be logging into the server and connecting to the database. That is not possible. If you have that kind of a requirement, then you will not be using RDS. So please here pay attention here. If you have this kind of a requirement in a scenario or in an interview question where they ask you to log into the server on a database, then you cannot use RDS. You will be using EC2 instances, and then you will be doing that what you call installation of Oracle SQL, whatever you want to run. You would be doing that by your own, and this service would be kind of a platform as a service, and that would be kind of an infrastructure as a service where you get the EC2 instance, and you would be installing your own databases, managing them, maintaining them, updating them, patching them. Here this is not required. Okay, you can only just use any client application to connect specific to your databases, and then can interact with the database. So the SSH will not be allowed, and it's very important to remember. Okay guys, now okay, I need to wait here because otherwise it will not make sense to you. Let's stop sharing. Let's go to the console. Can you quickly raise hand? How many of you are basically from database background? Anyone? Okay, so if you, as I said, this is a database services, we will find it under databases. You can see here databases, RDS, click on RDS. And this is your welcome screen, which gives you a bit of summary of your running databases and all those options which you have selected. Okay. Now, if you click on databases, you can click it from here. You can go from here. And if you already have snapshot or a backup lying in S3, you can restore from S3 as well. Okay. Let's click on create databases. Let's see what is the new console gives us. This is an older one. They keep on changing these dashboards and console very quickly. So if you come this week, you'll see something different. Next week, you see something different. Okay, if you look at it, they got two different options: standard create and easy create. And if you click on easy create, is you will not be, I mean, using most of the options. AWS wizard kind of an installation will happen if you click on this easy create, and then you select your RDS type of offering, and that's it. Like say MySQL, and it will just ask you whether you want production, dev, test, free tier, and it will now most of the options will take default and start creating database for you. Let's not do that. Let's go with the standard one. So where we'll see different options. What are these? Okay. So now if you look at it, this is basically Amazon Aurora's own database. So they will keep it first, and they will try to push it in on any opportunity which they get, where they can push it, right? So we'll talk about it later. First, we'll see this one. So these are common which you see normally databases like Postgre, Oracle, MySQL. So we'll take MySQL today, and we'll see what are the options which can and how we can install MySQL databases and we can work with it. Now, addition which we're going to use this would be MySQL community, and here are the versions. So you can select any version which you think of. I'll go with the default one currently, but if you think you need something different, you can go with that one as well. Okay, that 5.7.22, I'm going with that. If you need something else, and based upon your requirement, you can select the version which is there in the drop down list. Now it gives you a template, basically the kind of a template you require, whether you go for the production or it's a dev test or it's a free tier. It depends upon kind of a scenario you are dealing with. Okay, so in this scenario, if you go for the production, it will give you by default, you will have high availability and you will have provisioned storage and all by default, right? And when I say high availability, it would be creating those multi-AZ kind of an instance for you, and you need not to mention where it will be done by default. We're not going to do that. Instead, we're not going to put dev test also because we're going to stick with the free tier. But if you just have a dev test, then this would be a single AZ installation without any your provisioned storage. And if you go for free tier, here you will be restricted even to the type of instance which you can choose. Okay, so this is basically just to, I mean, have a look at it, feel it, how does it look like, those kind of requirement it has, right? So we're gonna stick with the free tier, and after that it'll ask you the database instance identifier, the one which I just spoke to you. So this should be the name of your instance, okay, and it should be unique across your accounts. So let's say we have let's call it Bhuvan DB or DB1. Okay, let's take this is the name of the database instance identifier. Again, this is the identifier to instance, not the database itself. Now, master username, let's stick with the admin. If you want, you can put another master username, and now you can either have an auto-generated password or you can create a master password. So let's create a master password. I'll go with the one which I normally do. Okay, so this is my password and this is my master username. Now you will have the database instance sizing. Currently, we do not have any other options rather than this t2.micro because we are going to stick with the, what do you call, we can't select anything else. So we'll stick with the db2 t2.micro, the one which gives and keep us in free tier with 1 CPU and 1 GB of RAM. Okay. Then the storage, you can have either general purpose SSD or provisioned IOPS. Okay, we'll stick with the general purpose SSD, but it will be chargeable. And currently we are putting 10 GB of storage, and maximum you can go 16,384 GB. And the more storage you allocate, you will have better IOPS. And once that is done, you have this storage auto scaling. Okay, what does auto scaling does? It can increase the storage for you automatically once the specified storage gets exhausted or about to get exhausted, and it can, here you can specify the threshold for the maximum storage when you enable auto storage scaling, because it can go up to 16,300 around 16 TB if you don't want that much of storage, because auto scaling will keep on increasing it. So here you can put a limit to that also, like how much you want. Okay. Guys, give me a second. Okay, let's move further. So this is what your threshold is, and we cannot have multi-AZ deployment because we are sticking with the free tier. Then the connectivity, here you can select in which VPC your this thing is going to run. So I'm not going to click on a new VPC because we have not done the networking thing yet, so we'll stick with the default one. And once this database is created, then you cannot change its VPC. Okay, so it's have to stick to the same one. Let's click on additional connectivity configuration. So you can have the subnet groups, whether you want the publicly accessible database or not. If you put publicly accessible, then it would be having a public IP, and then you can connect it from outside of your VPC. Security group, if you want, you can choose an existing one or you can create a new one. Let's create a new one. Okay, and let's give it a name. I'll want to call it my RDS SG. Okay. No preference for the availability zone. If you want, you can have the preference also, and the database port would be 3306. So let's keep it default. That is for the MySQL database port, as well as this is the port for the Aurora as well. So move further, then we have database authentication. You can have password based authentication, you can have password and IAM database authentication. So we'll stick with the password one, which I've already created the password. Now click on additional configuration. When you click on additional configuration, it will ask for the initial database name. If you skip that thing, then this wizard will not create a database. I mean, if I do not give a database name here, my database will not be created. Then I have to use those SQL based applications to connect to database instance and then create my own databases. So I don't want to do that. I just specify a name, which would be my basic one. Let's call it, what should I call it? Let's call it first DB. Okay, or it's first DB one. This is the parameter group, and the option group I'm going to tell you later on about this. This is what I wanted to show you, where you select it. Or shall I wait it? Okay, let's stop it here and go back to the PPT now. So this is where you where we are. We are on the database options, where we are selecting database names, and there are certain options called parameter group and option group. So I'm stopping this thing here and going back to the PPT. Okay, this is the place where we are, and I would like you to go through it once so that you can relate to what we just did. Okay, quickly, and then we can move to the next slide. Okay, cool. Let's go to the next one. So we have this options group. Basically, your options group, what it does, your database engines, we are using MySQL, PostgreSQL. There are a lot of, 6 database engines available. Every database engines will offer certain additional features, right? To manage your data and the databases, or maybe to provide additional security to database, which might not be there by default. Currently, we are going for all the options which are default options. If you want additional features which your database might have provided as an option, so you can create an option group to enable and configure those features, right? Now, when you associate a database instance with an option group, the specified options and option settings are enabled for database instances. Currently, what we are going through, we are only putting the default ones. If you need something specific and you know this is part of that options group, you can select that option group, and whatever features were there in that options group would be enabled for your database. Okay, like your RDS supports following options for MySQL. If you look at it, we have got 2 different options, which is audit plugin for MariaDB and the MySQL Memcached support. So you can see this is the option ID. If you want additional one, you can select an option group, and these 2 options would be available in MySQL what you're currently installing. Then we have parameters groups. So your DB parameter group acts as a container for engine configuration values that are applied to 1 or more DB instances, such as your character set, collation, etc. Your RDS defines parameter groups with default settings that apply to your newly created database instances. You can define your own parameter groups with customized settings and use them with your DB instances. You cannot change the default parameter group. Now, here you will have additional features. Here you will have basic DB engine configurations, right? So if you select the default one, so whatever character set, collation, etc., those kind of features will already by default enabled. If you want something else, you can create your own parameters groups, and those would be applying with the default ones. Okay, so let's stop here again and go back to the screen. I hope now the screen will make much more sense. So we have this data default parameter group. By default MySQL 5.7, and I don't have anything else. So I'll stick with the default. Similarly, the options group. This is what we have. We don't have a default one, right? Anything else we don't have currently. So now if we, okay, this is what the name is, then the parameter group and the options group. Let's go back further, talk about the backups. Again, it's very important. Sometimes it comes in the exam as well. So please pay attention here. By default, automatic backups are enabled. If you are not doing anything, your backups would be enabled. And the backup retention period would be for 7 days by default. So that's the feature of the RDS. Until and unless you go and disable it yourself, backups would be enabled. Okay. Now this is the retention period, and it is there from 0 to 35 days. If I just scroll down, like give me a second. It starts from 0 days windows to the 35 days. So what does it mean? If you are taking a backup, you also have an option to retrieve databases from this day to this date. If you need to restore your databases, you can go from 0 to 35 days. Okay. Now I'm not going to keep it 7 days, I'll keep it 0 days. Okay. Then the backup window. If you want that your backup should be performed at a specific time, you can select a window. And if you don't have that specific window, you can select no preferences. Now, when you will select this window, because when the backup happens, those guys who are working with the databases, you might have realized at that specific point of time, the database performance suffers for some or the other reason. Okay. So if you want my database should be backed up at a time when it is expected to have least load or no load at all, maybe in the midnight or maybe early morning hours or wee hours, that's kind of a requirement you have, then you can select a window and specify that limit. And if you don't have that kind of a databases requirement, then you can use for no preferences. Okay. So let's move further, and if you want, you can copy tags with whatever tag you provide, that will also be copied to a snapshot, because the backup will happen with the help of snapshots only. If you want, you can enable enhanced monitoring with the help of CloudWatch. We're not going to do that. If you want, you can export the logs, audit log, error log, general log, and slow query log. Basically, your error log would be enabled by default. Okay, this would be default by default. Other than that, audit, general, and slow query log, you need to enable it yourself. Okay. Then the maintenance. If you want AWS to have that auto update of the minor version, then you can enable it. Otherwise, you can, if you want that you don't want to get this done by AWS, you can remove this check mark. And what is the minor version upgrade? If you look at it here, this is my current MySQL version. Where we have this one. So 5.7.22. If tomorrow 5.7.23 comes, that would be a minor version upgrade. And if you want that, although you started from 5.7.22 and you want AWS to upgrade to that version, that would be known as minor version upgrade. Okay. So when it becomes 5.7.23, that would be a minor version upgrade. If you want that, when that happens and you want AWS to update it, then you can enable that thing. And here we found that this password is not valid, it's not confirmed. So let's do it again. Still invalid. Okay. Let me change this one also then. Okay, let me put another password. This is done. I'm gonna change this username also. I'm gonna keep it. Leave it. Let's go back to where we were. So I got this enable minor version upgrade. So we just keep it open because we are not gonna wait that long. We will delete once our demonstration is over. Similarly, you can select a maintenance window. because the maintenance would be done by AWS. So you can use either no preference, or you can select a window where you can specify, okay, this date you can done the maintenance for us. It would be almost for half an hour. So you can specify that window. If you want that your database should not be deleted accidentally, you can enable this database relation protection, which I'm not going to do. Then here it will start giving your estimated monthly cost. Okay, if you want to check that, and that's it. So our database is ready to be get created. Click on create databases, and you will start creating database for you. Okay, so once we are here, we can see the progress here. It's gonna take some time. So in the meantime, we can go back to our PPT and start discussing further options. And by the time it will get ready. Okay. Now talking about the backups. So okay, let's wait. Stopping the sharing here. Backups as well as manual backups for your RDS instance. You basically, your Amazon creates a storage volume snapshot of your DB instance, so backing up entire database instances and not just individual DBs. So what happens in the background? The snapshot of the whole volume of the storage volume of your database